We are going to be looking at graphing linear, parabola, and circle equations in this video. So first we're going to look at linear. So we know that from in algebra that we have it in slope-intercept form. That's how we're going to graph it. Y equals mx plus b, where m equals the slope and y equals the y-intercept. So if the equation is not solved for y, then you need to do that first. It's going to just make it easier in order to graph that. So on the first one here, we have y equals 2/3 x plus 1. So now, on here, it's already solved for y, and we're just going to graph that. So the y-intercept is 1, so I make a point right at 1. Go up 2, 1, 2, over 3, about right there. Or I can go down 2, because down is a negative. To the left is negative, and a negative over a negative is a positive. So that makes it a positive 2/3, and that's what I want because I want a positive slope. So that would be the graphing the y equals 2/3 x plus 1. And make sure you put arrows on the your graphs, so make sure it goes all the way across and put arrows on there. So let's say we had y equals negative 2/3 x minus 1. So on this graph, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5. Alright, on this one, the y-intercept is negative 1, so we're going to put a point right there. And then we're going to go down 2, 1, 2, over to the right 3, because it's positive, 1, 2, 3. Or we can go up 2, 1, 2, and to the left, because going up is a positive, to the left is negative. And we have a negative slope, so it'd be 1, 2, 3, and it'd be about right there. So I know these graphs aren't the best, but you can get the idea, and you've done plenty of these. So that would be the graph of those two. Alright, so let's say we had y equals 2x, and it looks like there's not a y-intercept, but really there is, because what I could do, I could put a plus 0 in there. So there's my y-intercept. So once again, on my graph, go to the y-intercept, which is be 0 right there. And my slope is 2, and it's usually rise over run, or it's always rise over run. And if it doesn't look in fraction form, which means it's rise over run, then you can always put a 1 underneath it, and there's your rise over 1. Go up 2 over 1 or down 2 over 1, and then you're going to connect those points, and then that would be your positive slope. Since the slope is positive, it's going to go up to the right there. For our next one here, we're going to do y equals negative 3. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Alright, so here we have a y-intercept of negative 3, but he's like, where is the slope? Well, once again, if you don't see something, just like the one before, we didn't see the y-intercept, so we could put plus 0 there. Same thing here. If you don't have a slope, we can put that in there. And there's our equation, y equals mx plus 3, or mx plus b. So our y-intercept is negative 3, so we're going to put a point there. And then since it's 0 slope, that means it's going to be horizontal. So all you do is draw a straight line right through that point there, and that is your equation for that. And we'll do two more here. We're going to do one with x equals 2. And that's going to be similar to what we just did here with the y equals negative 3. But this one's going to be x equals 2. So you just go to 2 and then just draw a line straight through. That's not very good there. That's a little bit better. So that'd be the graph of x equals 2. So that's that one. And then we have the graph for that one there. And we'll do one more here. Let's say we have 3x plus 4y equals 20. Alright, so from the very first slide I said you have to have it solved for y. So minus 3x minus 3x. So 4y equals negative 3x plus 20 divided by 4. divide by 4, divide by 4, so y equals negative 3/4 x plus 5. So in our graph, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Alright, so our slope, or excuse me, my y-intercept is 5, so up to 5. It's a negative slope, so I know it's going to go down to the right, the graph, when I graph that line. So I'm going to go down 3, 1, 2, 3, over 4, 1, 2, 3, 4, about there. I know my graph's not the best there. Or I could have gone up 3 and to the left 4, and then I would have had something that would have looked like that on there. So that would be the graph of that one, which is right because it would be negative slope, so it has to go down to the right there. Next we're going to be looking at parabolas, and they're usually in the form of y equals ax squared plus bx plus c. So if they're not, then we're going to solve for y, and that's going to help us to graph that. Now in this one, and the first one is linear, so nothing was squared, not the x or the y. On parabolas, the x will be squared, but the y will not. So if the x is squared, you know it's going to be a parabola. So the x has to be squared and the y will not be squared. So I made some drawings here of what parabolas look like. They just make a U shape. The dotted blue lines in the first graph, this first graph right there, number 1, is called the axis of symmetry. So basically it cuts the graph right in half, the U right in half. So the one side is exactly symmetrical to the other side, since it's called the axis of symmetry. And same with number 2. The dashed red lines are going to be the axis of symmetry. So it just cuts the graph, the parabola, right in half. So one side is exactly the same as the other side, so it's symmetrical. So if you would fold it on that dotted line, it would match up on the other side there. The point right here that I'm making at the very bottom of the U or the very top of the U on both the graphs here, that's called the vertex. The vertex is always at the very bottom or the very top of the U shape. It just means it's the point where the graph starts turning, going the other way. So if I was going on number 1 here, I'll do this in blue. So if I'm going this way, so right there is the vertex, and it's going to start going up this way. Same way here. This is going this way, and then it's going to start going down this way. So that's where it starts turning. And same way with on the graph number 2 there. To find the axis of symmetry, that line that cuts it right in half, we're going to use this equation here, negative b over 2a. So that's going to help us find that dotted line from the graph before that I showed you, and then from there we can draw the parabolas that make that U shape. So this equation here, y equals x squared plus 6x plus 9. My a is 1 because really there's a 1 in front of here. So if you don't see a number, there's a 1 there. Other than that, they'll put the 1 there, or the number there. B is 6 and c is 9 there. So to find my axis of symmetry, I'm going to take my b, and it's 6 because it's plus 6 there. So it's negative 6 because the equation up above there in the blue says negative, whatever your b is, over 2 times your a, which would be negative 6 over 2, which would be negative 3. So that's my axis of symmetry. So if I graph that, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Alright, so my axis of symmetry, actually I'm going to, that's going to cut right through there. So my axis of symmetry is right there at negative 3. So it's going to go through negative 3 there. And then from there, I need to find out how to find the vertex. So where's the U at? Where does the bottom of the U or the top of the U turn around at? Is it right on the graph? Is it down here, or is it up here? So we're going to try to figure that out there. Alright, and to do that, I'm going to take my negative 3 and put it into my equation. So I have negative 3 squared, so I'm putting it in my original equation, plus 6 times negative 3, plus 9. Negative 3 squared is 9. 6 times negative 3 is negative 18 plus 9, so I have negative 9 plus 9, which equals 0. So my vertex is going to be at negative 3, 0, and how I got that is because I put negative 3 in my equation for x, so that's my x value. And my y value, since it's equal to y up there in the original equation, came out to be 0. That's my point. So there's my point right there. That is my vertex. So that's where the bottom of the U or the top of the U, depending on how we're going to graph this and what the points are, that's what it's going to be at. So that's where it's going to start turning around or going the other way when we're going to graph that. Now to find those points on there, I'm going to make a table, and I'm going to go 2 points to the right and 2 points to the left. So there's a point there, so that's negative 2, so I'm going to use that equation, or that number, that point, and I'm going to go to also negative 1, and then 2 to the left, which would be negative 4, and one more, negative 5. So now, and I'm not going to be able to do this to show you because I don't have enough room here, I'm going to put each one of these numbers, which are my x, and find out the y. So I'm putting this negative 2, negative 1, negative 4, negative 5 into my original equation and solve it, just like I did at the very bottom to the left there in the blue. So if I put negative 2 in for x in my original equation, I will get out 1 there. Oops. There we go. If I put negative 4 in there, or excuse me, negative 1 in there, then I'm going to get 4. If I put negative 4 in there, I get 1, and if I put negative 5 in there, I'm going to get a 4. If I squeeze this in there, I should have put negative 3 in there just to show you, because we already know that negative 3 is 0. So I kind of squeezed it in there, because we already put that number, negative 3, in our equation, and we got 0. Then I went 2 to the right, 2 points to the left, put those in there, and that's what I got out for my points. So if I graph that, then I go to negative 2, 1, negative 1, 4, negative 3, 0, we already have, negative 4, 1, negative 5, 4, and then I can graph those points, connect those points, and there's my parabola. It's not the best looking parabola, but it's there. So you can see that axis of symmetry cut in half. So that's why it only makes sense that 2 points or more to the right, 2 or more points to the left, you're going to get those same exact answers for the right and the left for your y values because it's a parabola and it's making a U shape and it's going to be symmetrical. So once you go to the right of your vertex, your axis of symmetry, to the left of it, put points in there, those answers for your y values are going to be the same because of the symmetrical of the parabola. Alright, we're going to look at the same equation. Now another way to look at that is if I can factor x squared plus 6x plus 9, which I can, which would come out to be x plus 3 times x plus 3, which equals x plus 3 squared. So then if I can factor that, then when I graph that, I look at this number right here, and whatever it is, I'm going to put the opposite. Since it's plus 3, it's going to be negative 3. So that is going to be my vertex, negative 3. Let me write that better here. Negative 3, 0. So if you're able to factor your equation, which will come out like this, x plus 3 or x plus 3, that's just my example, which is x plus 3 squared, you take that number, in this case it's plus 3, take the opposite, and that is going to be your vertex and your axis of symmetry there. Then once again you just make your table of values, and we know then it's going to go up like this and up like that. Now if you're not able to factor it, you'd have to complete the square, and we're not going to look at that right now. That'll be in another lesson. So if you're not able to factor that like I did here, then you have to complete the square, and then you would be able to graph your parabola by finding the axis of symmetry, the vertex, make a table of values so you can get some other points and then connect all those points to see what the graph would look like then. Back there, then it was already solved for us, or we could write it in because it's factorable. But and then on this one, let's try one more problem here. So we have y equals x minus 2 squared. So it's already solved for y, and if I would multiply this out, I'd have x minus 2 times x minus 2, which would be, if I double distribute that, x squared minus 4x plus 4. Alright, so there would give me my a, b, and c. My a is 1, there's my b, and there's my c. Now we don't really need to do that, because I'm going to show you when it's already set up like this, you don't need to double distribute this to get this equation here. If you want to, you're fine, you're perfectly fine, you can do that. But if you don't want to, you don't have to do that. So to find my axis of symmetry, which remember is negative b over 2a, we're going to we're just going to look at this right here. We're going to take that right there, that number, and we're going to write the opposite of it. So it's going to be 2 then. So that is going to be my axis of symmetry there. Now same thing, if I would put this in my equation, so if I solved it, if I would factor this, or excuse me, double distribute, find that out, I'd have negative 4 over 2 times 1, which would be 4 over 2, which would be 2. So I got the same thing there. So if you did that and put it in your negative b over 2a, you'd find out that your axis of symmetry is 2. But if it's already in this form here, you don't have to worry about that. Just look at the number right here and write its opposite. So if it's minus 2, put 2. If it's plus 2, put negative 2. And then it's going to be 0 there. So if I'd graph that then, I go over to 2 and just put in my point there, and that's going to be my axis of symmetry there. So my vertex then, and actually I already kind of did that for you. I'm going a little bit fast to get through this here so we can get to circles. If I would put that into my equation, 2 minus 2 squared, 2 minus 2 is 0, 0 squared is going to be 0, and that's how I got that point there. So that's what that one is there. So I was already looking ahead, but that's what that is there. So anytime it's already in this form, like there, you can go ahead and double distribute it like I did if you want to and look at it that way. If not, then just look at that number and write its opposite. That will be your axis of symmetry. Put that number, mine is 2, this one example is 2, put that in your equation, solve it, and that's going to be your vertex. So that's where the bottom or the top of the U-shaped parabola is going to start curving and going around. Now if I made my table, I'd go 2 points to the right, 2 points to the left. So I'd go to 3, 4. I'm also going to put 2 in just to show you. Already know that's 2, 0. And then also to the left there, which would be 1 and 0. So if I put 3 in my equation for x, that'd be 1 squared, which would be 1. If I put 4 in there, 4 minus 2 squared, which is 2 squared, which is 4 then. And we have 0 there, put 1 in there, we're going to get 1, put 0 in there, and let me squeeze it over here. 0 minus 2 squared, negative 2 squared is going to be 4. Once again, like I showed you before, it's going to be symmetrical, so those answers are going to be exactly the same on each side of the 0 because it is symmetrical. So it'll be 3, 1, and 4, 4, and 1, 1, and 0, 4. So it's going to be there. I know this is kind of messy, but that's what that would look like. So back to, it wasn't, but if you want to, like I said, you can double distribute that and figure out what that's going to be with your A, B, and C. So either way. Our last one here is going to be on circles, and our equation for circles is x minus h squared plus y minus k squared equals r squared. X and y will both be squared, so that's how I know it's going to make a circle. If they're not no squares at all, it's linear. If the x is squared, it's parabola. If both of them are going to be squared, then it's going to make a circle. The center is your x and your k, and it's always going to be the opposite, and I'll show you that in a minute. And your radius is going to be, the r is your radius of the circle. So if I had x plus 2 squared plus y plus 3 squared equals 25. So my center is going to be negative 2. It's always the opposite of what they show. So if that said minus 2, then you put a positive 2. And then my y value is going to be negative 3. My radius is going to be what the square root of that number is, which would be 5 then. So this is going to be my center, and that's going to be my radius. So we're going to graph those, and I'll graph that on the next page there. Alright, so we have our center as negative 2, negative 3. Let's go to negative 2, down to negative 3, so that's going to be about right there. That is the center of the circle. Now for my radius, I'm going to go out 5 units. So 1, 2, 3, 4, 5, about there. Up 5. 1, 2, 3, 4, 5. I know this isn't the best graph. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And then you just connect them the best you can. Well, that's not too bad. So there's my circle. So the center, and we're going to do another one here like that. So the center is just going to be what your h and k are, and then the radius, you have to take the square root of that. Make your center, go out how many your radius would be, up, over, down, and connect them, and you have it then. Alright, here's another example. So we're going to find our center. And it's always going to be the opposite of what this is. So that's a negative 3, so we're going to write 3. That is a positive 2, so it's going to be negative 2. That's our h, that's our k. So that's h and k, and our radius is going to be the square root of 9, which is 3. So if I went there, go to 3, down to negative 2, and then we're going to go, our radius is 3, so go out 3, 1, 2, 3, down 3, 1, 2, 3, up 3, 1, 2, 3, and to the right 3, or left 3, 1, 2, 3. And once again, connect those, and that's going to be our circle. And like I said, this is your radius, so no matter which way you go, it's going to be 3 units there. Another example. So this one doesn't look like it has anything with the y, but we can put something with that. So this would end up looking like x plus 1 squared plus y plus 0 equals 4. Because y plus 0 is just really y. And then I have my square, so that's how we get that on there. So to find my center then, opposite. So my center is going to be negative 1. And then my y value of the k is going to be 0 in there. My radius is going to be the square root of 4, which is going to be 2 then. So if I went there, let's see. Negative 1, 0. That's going to be right there. My radius is 2. So go over 2, 1, 2, up 2, to the left 2, down 2, and then you connect them, and then there's my circle there. So if it doesn't look like there's something there, you can put a +0 there because that doesn't change it at all. Alright, our last one here. So you might have something like this, and similar to the one I just got done doing. So it's like, well, where's the h and where's the k? Because it's usually x minus h plus, or excuse me, x plus h and x plus k. So where are those at? So once again, you can go x minus 0 squared plus y minus 0 squared equals 16. So we'll look at your h, there's your k. It's the opposite, but it's just going to be 0, 0, so that is my center. Radius is square root of 16, which would be 4. So there's my center right there. Then I'd go out 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and connect those, and then there would be my circle. So my center is a 0, 0, and my radius is 4 on there. And the last thing on here, so this is just a review of all this, but if you had the radius, let's say square root of 5, then just take what the square root of 5 would be in a decimal form. So put that in your calculator or find out what the square root of 5 is. Find that, and that's how you would go out, how your radius would be. It's not going to be exact when you find your radius on the graph. You're just going to go out to 2 point something, but it's close enough. We're just generally looking to see what the graph would look like on there. Alright, so this is a lesson on linear, parabola, and circle equations and how to graph them, so hopefully this helped. Definitely go back over this. Don't not just take notes over it once and think you have it. It's here to use all the time. Go back over things you don't understand, and when you're doing your homework and looking at that, please go back to the examples on there. So good luck to you. Bam!